was talking about upcoming PDF 2.0 with people about 2-3 years ago, the discussion about encryption was on the table quite often. And I heard people talking, what's the deal here? Nothing has changed. Everything is pretty much implemented in every specific vendor applications. So what's new? And actually this statement is very close to truth. So you might wonder what I will be talking here about next 40 minutes. So I also realized from these discussions that people still don't understand quite well what encryption in PDF is all about, what security actually means, and they have false sense of security when applying some specific security approaches. And I believe that false sense of security is even worse than, giving away your PDF files for free without actually encrypting them. I also realized that even though the PDF can be secured and encrypted since 1.1, that's a real sentence from PDF spec, and it claims that since PDF 1.1, the encryption is used to protect its content from unauthorized access. That people still don't understand how does that work, what's possible and what is not. And I'd like to use this presentation actually to wrap up things and to kind of say where we are with the PDF 2.0 when it comes to encryption. Also a little bit about these misconceptions, a lot about technical things, and also maybe also about missed opportunities that we kind of missed with the release of PDF 2.0 in its state. So generally speaking, encryption in PDF is done by using the symmetric key algorithm. So you can see that as an algorithm that you feed with encryption key with the plain text, and you encrypt the portion, and then the same key is used to do the decryption. So you don't have two keys, just one. Okay, this is a general statement that applies since 1.1, PDF 1.1, and what is changing is the versions or the algorithms that we are using and the power of the size of the keys. So again, what it does, encryption, the term encryption is used to actually encrypt all the strings and stream in PDF files. So if you look at the PDF file, you have strings, you have streams. That's all what we are encrypting. We are not encrypting arrays, we are not encrypting names, numbers, nothing like that. PDF structure remains the same, just the content of a stream is changed. There are a few exceptions, obviously. You can't encrypt encryption dictionary itself. You're not encrypting metadata if you don't want to, because some workflows require accessing to metadata even on encrypted files. There are other special cases I'll talk about a little later. What it doesn't, or it can't be used to actually encrypt part of the content. So if you look at the page, you can't say, I want to encrypt just this couple of lines of the text, or bookmarks, for example. No, you can't do that. That's not possible with current state. Also, what's not possible, and where the misconceptions are, you can't really guarantee the reliable access restrictions. One, the PDF file is decrypted, it's opened, you can do whatever you want with it. Of course, applications like Adobe Acrobat or others won't allow you to print if the author wishes you to not to print or extract the content. However, that's just that's not a technical issue. The application itself has to follow opinion of an author. So if I'm doing the application, I can without a problem extract the content. There is no technical blocker for me to do that. And how is that done? It's done via Encrypt dictionary, which is located in a trailer. And this Encrypt dictionary says how the encryption key is computed, which semantic algorithm is used, and also the additional behavior of authentication. So if you have to pop up a dialog and ask for a password or things like that. Since 1.1, PDF 1.1, we've seen a lot of updates in this. Not in the general scheme, not at all. We still are doing the same thing. However, we were introducing a lot of versions along the way, a lot of different versions of encryption, so to speak. And there are 5 of those present in 1.7. And we distinguish between them based on the V entry in Encrypt dictionary. And if V is, for example, 2, then it is algorithm that uses RC4 algorithm, and the key length might be greater than 40 bits. Okay, that's for 1.7. In 2.0, we did this. We deprecated everything what's been used in 1.7, and on top of that, we added one more. So why the deprecations? It's easy, because it's not secure. World doesn't stop. Is moving very quickly, especially in these areas, and everything what is deprecated is considered as unsecure. Over the years, there's been attempt to break almost any algorithm, and the key length less than 256 bits are considered as unsecured these days. Okay, so this is what happened in 2.0. So change happened, and now obviously there are questions. What can we as developers do with all the old algorithms? Shall we support them? Shall we not? What should I do as a developer? And in 2.0 files, they are legally deprecated. You can't use them. And I'm not thinking that because it's a legal requirement, by legal. It's in spec, so it's a legal requirement. The more important thing is don't use them because they are unsecure. And that's the false sense of security that we should consider when doing our development and, trying to protect our data here. When I'm developing 2.0 consumer or viewer, what should I do? Should I still support opening those files? Because they are out there, They are out there, and as Matthew mentioned in his previous presentation, you probably want to still support opening, so decrypting those files, because you will become them. You will receive them from your customers, and you don't want to end up with unreliable software. So yes, but never ever create files that are not that are encrypted with the deprecated algorithms. And then another question: what can I do when I want to use 256-bit AES encryption, which is in fact the one that is green, the only one that is green, in my 1.7 files? Can I do that or not? Well, maybe you can. Thing is, everybody does that. And that there is a historical reason why are people implementing, or why were people implementing that. I will speak about that a little later or on the next slide. So everybody does that. Everybody uses the AES 256-bit encryption in 1.7 files as well. But there is a perfectly legally way how to do that, and I will explain that to you now. So to better understand what's the status of the currently used or is currently supported AES 250-bit encryption, we have to look a little into past. Sorry, in June 2008, so which is after the 1.7 was released as ISO 32001, Adobe published a supplement to the ISO 32000 extension level 3, and they, Adobe, introduced this usage of this new algorithm, and companies started to adopt it very quickly. This because, you know, if you care about security, this is the right way. Fun fact is that in December 2008, hackers found the weaknesses in this algorithm. Shortly after that, Adobe published a revision called Extension Level 8. This is a publicly available document, and ISO 32001 knows a language how to use extensions to the standard. You simply put in a root language that's there. The file uses extension, Adobe base level, extension level 8, and that's it. You're safe. It's not a big burden to do that. To be honest, nobody does that except of the Adobe. If you save file in all the Adobe Acrobat. However, that's the perfectly right way, and I would encourage you to do that in your applications because it doesn't cost much and it is the best practice. Another feature that's been kind of not used as much as possible is script filters. They are known in PDF like forever, so to speak, and it is a very powerful language. And I think we have one small missed opportunity here, that we are not using this language a lot better. The fact is, as I mentioned, you can specify or you can the basic scheme encrypts and decrypts streams and strings in a file with the one single encryption key. Crypt filters can be defined on each stream. You can use script filter as a flat decode, for example. So you can say this stream will be encrypted with this specific crypt filter. That way you might get, theoretically, you might get several different encryption keys used on different streams, right? However, well, as I mentioned, for implementers, there is a consequence. We don't have just one encryption key, but we would need to keep track of all the encryption keys based on used encryption encrypt filters. The reality in 1.7 as well as in 2.0 is that only 2 crypt filters are allowed in PDF 2.0. So you have to come up with your own if you want to. Nobody would understand it. Or you can, in fact, use just 2. One is identity, which means a stream won't be encrypted at all. Another one is the standard one. So I believe this is something as a missed opportunity that we are not introducing a lot more here. Very quickly, I would touch the 2 basic schemes that are introduced in PDF. One is standard security, so-called password protection. You can define in encryption dictionary, you identified via filter standard, and you know, or you can use 2 different passwords. One is user password, as known as open password. You can't open a document without entering it, or the end user. And there is another one, password, called owner or master, or change security password based on what document you're reading, and that's is used just to change the security. Of course, permissions are attached to this, and also a flag to encrypt metadata. Consequences of this scheme that people don't really realize. It doesn't make sense to set a permission if there is no owner password, right? Because if you can open the file, there is no owner password. that would disallow you to access the change security dialog. So you will be able to change the permissions there. Also, if user password is not set, everyone can easily decrypt the file. Nothing protects you from decrypting the file. So the file is actually publicly available no matter what you think. Even though it's encrypted, but the authorization, you can write an authorization code that generates the encryption key right for you. And also we have to mention that PDF viewer has to respect the permissions, because once the file is decrypted, the content is accessible, available for you, so you can do whatever you want with it. And also something what people don't realize, once password is set, PDF is out there, you can't really take it back. You know, the PDF, you can't revoke the access to the document. I don't think I have that much time to go through all the details, so very quickly, how does that work? If you are encrypting a file, you have a file, you generate as a random value file encryption key. You have a user password, you have an owner password, then you fill something in the encryption dictionary from user password, and then from the owner password, there are algorithms that are described in PDF specifications very precisely. So it's mainly doing a hashes from that. And then you are encrypting with those hashes the file encryption key, as well as permissions. If you want to open the file, you do basically quite the opposite. Entered password is again hashed with the same algorithm, and you compare it to stored value, and if the stored value is the same, then you can get with the symmetric decryption algorithm the file encryption key, and then the key is used to decrypt the content. Okay, very, very simple. Let's move on. There is another scheme in PDF that people don't use very often, and it's very powerful. And I think it's a pity that the adoption is so bad, or is not as good as with the password, because it provides you a lot better control over the access. And it's called public key security handler. So filter in encryption key is again of the type Adobe PubSec. A subfilter could be, for example, PKCS7.S5, and the basic idea is to encrypt the file using recipient's public key. So recipient provides a public key, you encrypt the file with the public key, and only the owner of the private key can decrypt the file. As with passwords, you can set crypt filters, however, only one is allowed. This scheme also offers you to add more recipients to the document with different permissions. It works something like that. So you generate random value file encryption key, and then with the John's public key, you encrypt the file encryption key that's stored somewhere, and when doing in an array, and when doing the authorization on end user's computer, you are going through private keys and through the recipients and trying to decrypt the key, and then the key is used to decrypt the content itself. Current status in ICO 32-2, no updates, no deprecation. File encryption key is generated from 24 bytes. We are using a seed random value plus we are adding permissions. Current Vault offers you actually use of 32 bytes in AES file encryption key, which gives you a little bit of security hole here, and I think that's again something like a missed opportunity when doing this update to 32,000-2. Also, we are allowing in PDF 2.0 all PKCS7 certificates without restrictions. I'm not any cryptographic expert, but there are several weak, considered to be a weak certificates out there. We probably should call them out of scope or deprecate them. There are no new methods introduced in 32,000 in PDF 2.0 like elliptic curves, and although they are endorsed since 2009, yes, you can use or you can trick the algorithm to use them if they are encapsulated in your certificate. That's the way, but we are not encouraging people to use it properly. There is another way, or companies that are dealing with security are coming up with custom security handlers, so-called custom. It is something what is outside of the scope of the PDF specification. It uses the language, and also it uses the power of Adobe Acrobat and SDK, as well as other SDKs. And it simply, instead of providing encrypt dictionary into a trailer with the standard name, you will provide encryption dictionary with filter of your name. Then you can store whatever you want in the encryption dictionary. You can also better control the access, and you can override the standard behavior. And also, you have to, or your code has to provide the way how to calculate the file encryption key. Still, the base is the same. Your custom security handler generates or provides file encryption key, and the code in Adobe Acrobat or whatever viewer you're using will use this encryption key to decrypt or encrypt the streams and strings. Okay, we've seen a lot of implementations out there in the wild, and it's worth to mention that you actually have to provide a code into Adobe Acrobat, into Adobe Reader that understands your encryption dictionary via plugin or via having a contract with Adobe or with other vendors as well. So the code has to be there, right? We've seen a couple of examples, a couple of companies doing this in this specific way. Like, for example, I did a couple of screenshots. This one is filter called Microsoft IRM services. It's so-called RMS1, yeah, something what Microsoft introduced a while ago. And they have their own entries in the encryption dictionary, and they have to provide the code how to actually digest or calculate the file encryption key for the decryption and encryption. They have to also provide a code that does the authorization. It can go either to web, or it can ask for a password, it can ask for, I don't know, your whatever, blood. Okay, we've seen also other implementers doing this, and like this one is, for example, from FileOpen, company called FileOpen. They are doing DRM applications. So their code can also do, or you can actually, via this mechanism, to revoke access if you have the code for that. If you have the option there, you can also provide better control over the permissions, because the code is yours, right? You can disallow that. Another implementation that just recently came out is from Foxit, called Connected PDF. Do you have someone from Foxit? No. They also use this custom. Okay, sorry guys. They use custom security handler to actually encrypt the content of the file. And I've long time no seen the Adobe's one. Adobe does have, it was called ebook, something. Nowadays I don't know what's the name of the product. But again, they are building the generating PDF file with custom security handler, and they are providing all the information they needed to, and also all the code. The thing is with custom security handlers that you can't really predict, if you generate the PDF file, you can't really predict if your customer or end user will have the right viewer, right? They might use, I don't know, Foxits, Nitros, Adobe's, and the code might not be there. The plugin you're requiring might not be there. So what do you do? So far, you end up in a situation where simply Adobe Acrobat will pop up a window saying, I have no plugin. Just download it somewhere, and then it might work. So not the best user experience. And something that is something what's been addressed back in 2015 when Microsoft introduced the RMS at that time called IRM protection, and so that's the basically this one. And they came up with an idea that they used the update, it's called the update of a PDF file. So it's called update. If you have two files.
So embedded file?
No. No. Never mind. Never mind. So if you save file and then you do again a save with a couple of updates. Incremental. That's the word. Exactly. So they use this tech.
It's on your slide, actually.
Is it? Ah, yeah. Good. Thanks.
It helps.
So they used incremental update techniques to get around this. So what they did, they encrypted the file, the whole file, and then they added another file, which was only one page, saying, well, you don't have the right plugin, and the file would jump right in front of you, and you wouldn't get access to the encrypted file, you know, unless you do have a plugin that recognizes something written in a trailer. It was wrapper at that time, and if the plugin recognized that, the plugin would go directly to the original file and would decrypt it. In 2.0, we introduced something like unencrypted wrapper. We didn't use this technique, but we used different techniques around associated files, and it really is all about giving author the control what message the end user is going to see when he doesn't have the proper plugin or doesn't have the proper viewer. So the author can control the message. The author doesn't rely on the information that viewer will show. It will just pop up for you, and the message could be your marketing message, information, how you can access the plugin, or how you can get access to this document. There could be a link that will point you directly to a website where you can open your account or whatever. So that's the idea. And basically, we now need two files. One is message for the end user in unencrypted form, And then we do have the encrypted file. And Reader app has to decide which one to show. And in 2.0, we, as I said, we introduced a feature called unencrypted wrapper. And how does that work? It is using collection, or you might know it as portfolios, with few additions. So we are defining associated file with file specification. We are providing key EF, which is the encrypted file. And then we have to define AF relationship, as I mentioned on the session with tagging. And AF relationship in this case would be encrypted payload, and you provide also the dictionary or definition of the type of this associated file. And then you define in collection the D parameter, which points to the encrypted payload and the view. So you got the idea what happens when you open such file. If the viewer looks at the collection, looks at the D and default view, and goes straight to the associated file, which is encrypted payload for us, and if he knows what to do with it, he decrypts it, and there you go, you have your encrypted file. If he doesn't know what to do with it, if he doesn't know or doesn't recognize the encrypt dictionary in the encrypted payload, he just shows the original file. Yeah. This implementation does have consequences, and they are not small, so let me recap them. First of all, application that doesn't recognize collections, like for example Adobe Acrobat 7, shows the default file. Right? You won't get to the encrypted file. You won't be able to actually make that happen, right? Also, the application that knows collections, so portfolios, but doesn't recognize the unencrypted wrapper, doesn't recognize the encrypted payload, AF relationships, or stuff from 2.0, they would try to show encrypted payload instead. So you would end up in the same situation as before on old applications. So again, I guess we missed a little bit of opportunity here, and we are providing, or we are actually generating, or we can end up in a situation that's very user unfriendly with this, unless applications are properly updated and they do have the proper support for portfolios as well as encrypted payload. Okay, there is another bucket of applications out there that go beyond PDF. They are used for encrypting and controlling access to anything, not just PDF, basically. And we know a couple of those. They all require special viewer because the content is encrypted as a whole. So PDF is used as a one stream of data that is encrypted and put into some specific file format like PDC, DRMZ, PPDF, and so on and so on. This is something what we see as a growing, these implementations, and the advantage for developers to use this approach is they can code it once, and they can use this as an envelope for any other format, JPEG, TIFF, whatever, right? And they can completely, because they have to provide their own viewer, they have to completely, or they could completely control the permissions, tracking, revocation, complete control. We know something like PPDF, which is Microsoft's Azure protection. It's RMS 2.0. They do have their own viewer, and they simply take PDF as a stream of data. They provide this, and it's connected to an Azure environment where it takes, or where author can control all the properties, all the access. You can revoke, you can do whatever you want there. Okay. There are also other implementations that might be interesting for the group, for the people, and they are a lot harder to do, especially with the context of PDF itself, not to mention the special cases where you take the whole PDF as a whole. So we've seen, again, also a couple of those applications where people are trying to control the portion, access to the portion of the text, of the content. Like, I don't want you to see this specific table. I don't want you to see this specific paragraph. I don't want you to see these pages at all. And there is one interesting implementation which does this. In a PDF inside of Adobe Acrobat, you can revoke access. You can define whatever the end user with a specific role can see, and then you can reveal it for himself and, you know, redact it if he doesn't have the access to it. There is no scheme in particular in PDF how to achieve this. So everything, the authors of this application had to do their own handlers. They had to do their own redaction, take away the content that is in there, put it somewhere else, and when you have the data, they have to put it back, and so on. Nothing like this is easily doable in PDF these days. So, to wrap this up, I think as I mentioned at the beginning, there is a lot of misconceptions. People still believe that they are secure where they are not. PDF 2.0 brings a couple of interesting things to the market, like unencrypted wrapper, deprecation, which is something what I believe is a very important message for all the developer and all the adopters as well. As soon as things are deprecated, people should not be using it. And I think there still is a couple of places where we can improve, where we can bring some more stuff to the market when it comes to a controlling access, revocation, as well as encrypting of part of the content. So I think we are close to the end, and I'll gladly take your questions. Thanks.